many shortest lattice path starting from 0, 3 and end at 3, 0. So what is this? So a lattice means we are on a grid. So these are grid. What is lattice? Basically, it's the cross point between the lines. So these are all lattice. Okay, and then what? Well, it says from 0, 3 to 3, 0. You can think of it as x is 0, y is 3 to x is 3, y is 0. So like this. So how do you count how many points, how many ways you can move from point A to point B? Well, the most easiest naive solution is brute force. You draw all the possible outcome. But of course, you will very soon realize this is not a good approach. But you can learn something from these figures. So if you see that to reach B from A in a shortest path, so here shortest means you cannot go back. For example, from A to B, you can only move east or you move south. Can you move north? No, because if you move north, you're going back. It's not shortest, you're increasing the length. Can you move west? No. If you move west, you are also increasing the length. So you can only move south or east. So south or east. These are the only two possibilities here. And if you look at this figure, moving from A to B has 6 steps. For example, E, 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 S, S, S. So what does it mean? This E, 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 S, S, S means I have move E, move E, move E, and then move south, and then move south. What does it mean? It means I move to the east 3 times, and then I move to the south 3 times. Then let's say, what about the second one? This is like I move to the east 2 times, and then I move to the south, and then I move to the east, and then I move to the south, and I move to the south. So this means I have E, and then I have E. The third one is a S, and then the last 3 one is a ESS. ESS. So that means for the second one, it is EES, ESS. Okay. Let's say, what about this one? It will be ES, ES, ES. So for this one, it will be ES, 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 and so on. Then the question is, how many possible ES things? The key here is to understand this is the same as what? In 6 boxes, you put 3E and 3S. 6 boxes. These 6 boxes correspond to what action you do from moving from A to B. So that means in each boxes, you can what? You can put an E here, or you can put an S here. And the question is, how many ways can you allocate the E and S such that there are 3E and 3S? Notice that. Can you have 4E or 2S? Can you have that? Let's see. If you have 4E, that means what? You have to move, in the end, 4 units to the east. You will be somewhere here, okay? And furthermore, if you count 4E and 2S, that means you can only move 2 units down. So for 4E to S, in the end, you will be somewhere here. That is 4 units to the east, 2 units to the south. This point is not B. This point is somewhere else. So that means 4E to S is impossible. In other words, for this particular setup, you are only allowed to select 3E and 3S, and that's it. No other choices. You cannot say I move 1E and then 5S. No, this is not allowed. You are only allowed to select 3 east and 3 south. So the question is same as, how many ways can you put 3E and 3S in 6 boxes? So that means I now have E and S. I am only allowed to point 3 arrows of E in among the 6 boxes, and I'm also only allowing to point 3 arrows of S into the remaining 6 boxes. So that is 6, choose 3. 6 box, choose 3E. That means I have 6 boxes. How many ways to select 3 boxes for me to hold this 3E? And then the remaining 3 boxes will be for the S. Okay? Or you can think of how many ways can I choose among these 6 boxes? I select 3 boxes to put S, and then the other remaining boxes I put E. Let me give another example. Okay, now I'm asking how many ways from 0 to 4, 0 with the shortest distance are possible. So what's the first step? First step is, what's the length? Okay, what's the length of this process? By looking at the figure, you will see that it's moving 4 units to the right and then 2 units down. So it will be what? 4E and what? 2S. So that means what? 6 steps. Okay, also 6 steps. Okay, 4E and 2S. And then here's the thing. Can you have 3E and 3S? No. Why? Because if you have 3E's and 3S, first of all, what does 3S mean? 3S means no matter how you go, you need to move 3 units to the south. In the end, you will exceed this point because it will be somewhere here. But now I'm asking you from moving from 02 to 40. 3S is impossible. Okay? And similarly, can you have 1E and 5S? No. Why? Because if you move 5S, that means in the end, you have to move 5 units to the south. 5 units to the south will be somewhere here, which is not here. So therefore, it's impossible. So in this question, what's the logic? The logic is you have 6 boxes. 1, 2, 3, 4, 5, 6. Now you are only allowed to select E and S. And what? More specifically, you need 4E and 2S. It's not just arbitrary. You can put any boxes as E or any boxes as S. That means all of them are E. Is no, you can't do that because all of them are E means you move to here. Okay, you exit. Okay, no. You need to find explicitly 4 boxes for the E and 2 boxes for the S. So that means what? That means it's like you have 6 boxes, you choose 4 of them to put the E, or you have 6 boxes, you choose 2 of them to put the S. And don't forget, they are the same. Why? Because nk is same as n minus k. Okay? So for example, and solution will be E. So what does it mean? This one means E. So this is a solution. I can also say that, what about E. So what is this? E. You see? So the red one and the yellow one are different, but they are both 6 steps solution from A to B. So how many are possible? This number. In general, the shortest lattice path from 0, 0 to mn is m plus n, choose m. How do you prove this thing? Induction, okay? You can prove this by mathematical induction. Mathematical induction is not the focus here, so I'm not going to talk about it. So with this theorem in mind, just let you know, this is also true, okay, because of symmetry in the binomial coefficients. So therefore, for example, 0, 0 to 1, 1, how many ways can you go? So let's draw a grid. You can go like this, right? Or you can go like this, right? So there are 2 ways. So if you compute using this way, m plus n, so 1 plus 1, and then m is 1, so you have 2 choose 1. 2 choose 1 is 2, okay? From 0, 0 to 2, 2, so 0, 0 to 2, 2, so this is 0, 0. 2, 2 is here, 2, 2. How many ways? Use this formula, it will be 2 plus 2 choose 2, which is 6, and the figure here are all the 6 possible lattice paths you can do. From 2, 2 to 3, 4, okay, 2, 2 to 3, 4, let me draw. Let's say this is 0, 0, okay, 0, 0. So 2, 2 will be here, okay, this is 2, 2. Okay, let me draw a coordinate here, okay. 3, 4, so 1, 2, 3, this is x is 3, okay, y is 4, 1, 2, 3, 4, so this is 4, okay, this one is 3, 4. So it's saying how many ways can you travel within this grid. So how many ways can you travel from here to here? This is the first way, this is the second way, this is the third way, okay, there are 3 methods. How do you make use of the formula? So the formula is saying that from 0, 0 to mn, you have this formula. But now we are not starting from 0, 0. So what you can do is you change the coordinate. So instead of using this black thing as a coordinate, why can't we use this red thing as coordinate? If I use this red thing as a coordinate, what's the changes? I'm just shifting from this coordinate to here. So basically this shifting is that x minus 2, y minus 2, right? So if I change everything by minus 2, this becomes 0, 0. This becomes 1, 2. Okay? So now I'm asking, what's the number of lattice path from 0, 0 to 1, 2? 1 plus 2 divided by 1. Or 1 plus 2 divided by 2 because of symmetry, which is 3. Okay? That's it. 3 way.